There was this asteroid that collided with Earth over Chelyabinsk in the Soviet Union, in Russia, sorry. That was visible to everybody in broad daylight, and you had to avert your eyes when it happened. And they felt the shockwave, and the shockwave broke windows and sent nearly 1,000 people to the hospital.
Scientists believe that billions of years ago, asteroid collisions may have brought essential ingredients for life to Earth. Over time, additional asteroid impacts contributed crucial elements that helped shape and sustain life. However, not all asteroid collisions have been beneficial. Some have caused catastrophic events, including mass extinctions that wiped out large portions of life on Earth. Despite these disasters, our planet has remained a cradle for diverse species for billions of years. While we hope to avoid future asteroid impacts, their movement lies beyond human control. Many asteroids in our solar system possess the potential to cause immense destruction if they were ever to strike Earth. Though some have passed dangerously close, none have yet inflicted harm. Scientists tirelessly monitor these celestial bodies, studying their orbits to assess potential collision risks. But what if our understanding of asteroid motion is incomplete? What if an unknown force is influencing their trajectories? Recently, while analyzing an asteroid's path, researchers made a startling discovery that has intensified concerns. As a result, they are closely observing an asteroid called Apophis, which is set to pass alarmingly close to Earth in 2029. But what exactly did scientists uncover? And why does Apophis' approach raise such serious concerns? A glimpse into the past. In 2023, on a bright morning in the Utah desert, a spacecraft returned to Earth after one of the most remarkable journeys in the history of space exploration. Having traveled over 2 billion miles, it carried within it a precious time capsule, rock and dust collected from an asteroid named Bennu. This asteroid, shaped like a spinning top and measuring about 500 meters across, has remained virtually unchanged for over 4.5 billion years. Scientists believe that Bennu holds organic compounds, primitive molecules that may have played a role in the origin of life on Earth. In October 2020, NASA's OSIRIS-Rx spacecraft successfully landed on Bennu's surface, collecting material that has already yielded invaluable insights into the early solar system. Among those analyzing the asteroid's data was physicist Udi Sai of Los Alamos National Laboratory. As he examined Bennu's precise orbit using OSIRIS-Rx data and previous ground-based observations, he noticed something unexpected: small, almost imperceptible deviations in its trajectory. Could this be evidence of an unidentified force acting upon Bennu? Sai and his team suggest that a subtle yet unknown influence may be altering Bennu's path. Scientists often compare such anomalies to a game of billiards. Imagine playing on a seemingly level table, only to find that the balls veer slightly off course, as if nudged by an invisible force. If you cannot see any apparent cause, you might begin to suspect that the table itself is subtly tilted. In the same way, the unusual variations in Bennu's motion hint at the presence of a force that remains beyond our current understanding. The concern over Apophis. This revelation raises significant concerns, particularly as Apophis approaches Earth. On April 13, 2029, this asteroid, measuring about 370 meters in diameter, will pass within just 20,000 miles of our planet, so close that it will be visible to the naked eye in certain regions. Although current estimates suggest that Apophis will not collide with Earth during this pass, even minor miscalculations in its trajectory could have serious consequences in the future. For years, astronomers have studied Apophis' orbit, but recent findings have introduced new uncertainties. The discovery of unknown forces influencing asteroid movement has heightened concerns about potential risks. Scientists plan to use Apophis 2029 flyby as an opportunity to study its trajectory in detail, aiming to refine their ability to predict its future movements more accurately. Adding to the uncertainty, Canadian astronomer Paul Watt has challenged earlier assumptions about Apophis' orbit. His research suggests that, while Apophis is currently not on a collision course with Earth, even a small impact with space debris could alter its trajectory. His team's simulations indicate that an object as small as 0.6 meters striking Apophis could push it into a gravitational keyhole, a narrow region in space where Earth's gravity could significantly change its path. If such an event were to occur, there is a minuscule chance that Apophis could be sent on a collision course with Earth in the future. However, the likelihood of this scenario remains incredibly low. Watt's calculations estimate the probability of such an event at less than 1 in 2 billion for 2029 and under 1 in a million for a later impact. Even in the rare event that Apophis' trajectory is altered, only about 5% of those changes would result in a direct collision with Earth. Nonetheless, this research underscores the unpredictable nature of space, where even the slightest deviations can have far-reaching consequences. Preparing for the unexpected, Apophis is not the only asteroid under close observation. Scientists are also monitoring 2007 FT3, an asteroid roughly 340 meters in diameter, which has a 1 in 11.5 million chance of colliding with Earth on March 3, 2030. Meanwhile, NASA recently conducted a global exercise to evaluate preparedness for an asteroid impact scenario. In this simulation, astronomers detected an asteroid that had gone unnoticed due to its orbit around the Sun. The scenario suggested that this asteroid, large enough to cause severe regional devastation, could strike Earth in 2038. Initial estimates placed its size between 60 and 800 meters, with a 72% chance of impact. However, due to its position behind the Sun, astronomers would be unable to observe it for a crucial 7-month period. This exercise revealed a stark reality. Humanity is currently unprepared to prevent such a disaster. Existing technologies, such as kinetic impactors or nuclear interventions, require years of development and testing before they can be considered viable solutions. The simulation served as a sobering reminder that planetary defense must become a global priority. The challenge of the unknown, beyond the risk of asteroid impacts, scientists are now grappling with an even greater mystery, an unidentified force affecting asteroid motion. The unexpected behavior observed in Bennu suggests that subtle but influential factors may be at play, ones that remain beyond our current scientific understanding. These gaps in knowledge make it increasingly difficult to predict asteroid trajectories over long periods. Even the slightest miscalculation could lead to dramatically different outcomes, including the possibility of an asteroid being nudged onto a collision course with Earth. As researchers continue their investigations, one thing remains clear: space is far more unpredictable than we once believed. The forces shaping the movements of asteroids may hold secrets yet to be uncovered, secrets that could determine the fate of our planet.